Welcome to Summarize Science, where we break down cutting-edge research. Today, we're looking at a fascinating question. AI can write code, but does it actually understand it? Large software projects can have thousands of files, and understanding how they all work together is a huge challenge. To test this, researchers introduced a new task called GISTIFY, which pushes AI coding assistants to their absolute limits. The idea behind GISTIFY is simple but brilliant, as shown in this diagram. You give an AI a huge codebase and a single command, like running a specific test. The AI's job is to create one single, self-contained file that perfectly reproduces the behavior of that command. It has to trace the command through all the different files and pull out only the essential pieces of code needed for it to run. And the rules are incredibly strict. The final file must run independently, produce the exact same output, contain the absolute minimum amount of code, and not include any hallucinated or fabricated code. This ensures the AI can't take any shortcuts. It has to truly understand the program's execution flow. The researchers tested several top-tier models, including GPT-5 and Claude 4, using different agentic frameworks. These frameworks allow the AI to perform actions like reading files and navigating the codebase, mimicking how a human developer would work. So, how did they do? As you can see from this table, not great. Even the best-performing combination of model and framework only achieved a success rate of about 61%, meaning it failed nearly 40% of the time. This next table gives us a look into why they fail. The most common issue for the top model, Claude 4, was PyTest runtime error, meaning the code it generated simply crashed or produced the wrong output. For GPT models, a major problem was missing test function, where they failed to even correctly copy the main piece of code they were supposed to be analyzing. This suggests a fundamental gap in their reasoning process. The researchers also found that the task's difficulty scales dramatically. This graph shows that as the execution trace gets longer or touches more files, the AI's success rate plummets. Essentially, the more complex the task, the more likely the AI is to fail. In one experiment, they gave the AI a cheat sheet by providing it with the exact execution trace of the command. Unsurprisingly, this dramatically boosted performance. This confirms that the hardest part for the AI is figuring out which code is actually being run and in what order. So, let's recap the important points. The GISTIFY task is a powerful new benchmark that reveals the current limitations of AI in deep, codebase-level understanding. Even state-of-the-art models struggle to reliably trace and extract functionality, especially as complexity increases. However, as AIs get better at this, they could become incredible tools for developers, capable of automatically isolating bugs or features into simple, easy-to-understand files. This research gives us a realistic look at where AI stands today and the exciting possibilities for the future. If you enjoyed this summary, please remember to like this video and subscribe to Summarize Science for more.